Okay. You can hear me, right? Hello.
Yes, madam.
Okay.
Yes.
Okay. Let us not delay more. So we can start. This is going to be the solve with the session for week 7. Okay. So have you already seen the week 7 lectures?
Yes.
Okay. Yeah. And yeah, was it understandable? Was it understandable?
When we hear and see, it is understood, but we
Mhm.
need some practice in hand.
Yeah.
Be
So
confident.
basically, we started sequences and limiting concepts. And the limiting concept, like for this type of thing, its main key is practice. So you have to practice those things. Yeah. Overall, it was okay, right?
Yes, concepts are clear now.
Okay. Very good. Okay. So we can. Yes.
Ma'am, please share the previous TA session recording Excel sheet.
Okay. Okay. I will provide the access.
Please, ma'am.
Yeah. Yeah. Sure. I will provide the access. Okay, tonight I will provide you the access. Don't worry about it. Okay.
Yeah, it was asking for a request for access, ma'am.
Yes, yes, yes. I know I have to change the access thing.
Ma'am, please share in the chat box.
So you do have the Excel sheet and links are pasted there, right? I will change the access permission and you can then open directly from there. Okay. Any other queries? Doubt? No? Okay. Then we can start. So as you know, solve with the session is like we will pick some randomly selected problem and we will solve it together. Okay. So
Ma'am, these are from the PYQs, previous year
no,
questions, or
no.
different?
These are just randomly picked some.
So PYQs, when you for this week's week 7 PYQ, when you will address in the next session, or it will be towards the revision sessions?
Okay, I haven't decided it yet.
Okay.
So I have to decide it and we will then let you know.
Fine, fine. Okay, right.
Probably it will be like the before revision sessions.
Yeah, because if you can sort of cover PYQs also as part of the weekly sessions, it will be easy for us because we know what we can expect in the next term. I mean, quiz 2. Rather than piling up everything towards the revision session, we would rather want to have few PYQs also to be addressed in the weekly session, if you can. I mean,
Okay, okay.
I
We
don't
will
want.
try. If we
Yeah,
get time, then we
sure,
will
sure.
try to
Okay,
do that.
right,
Like
right. Thank you.
also we have to follow the deadline of your graded assignments, right? So
Correct, correct.
yeah, if we got that much time to cover
Sure.
these things before the
Okay,
deadline, then
no
we
problem.
will do that. Okay.
Right, right.
Yeah, yeah. Okay. So yeah, this is the
Ma'am,
first. Yeah.
ma'am, Excel sheet directly attached to the calendar, na?
Yeah, it should be attached to the calendar.
Okay, ma'am.
Yeah. I will update the permissions so you can access the videos. Okay. So yeah.
Excel in the chat bot because we got during the qualifier. I have that Excel, but I'm not sure that whether that is the updated one.
Okay, so if you have, we are following the single Excel sheet. So the later videos also, they will paste the link in that the previous Excel sheet also. So if any one of you have the Excel sheet, the link of the Excel sheet, you just paste them in the chat box so that you can get it. Okay.
Okay, madam.
Yeah.
Okay, ma'am. Please.
Okay, so let us now start our discussion. So this is the first question. I'm giving you some time. You just try to solve or try to find limit of the sequences. and try to find which is the correct option, is or are. There may be more than one correct option. Just try to find it. Okay, I'm giving you 5 minutes to solve this. You are solving it, right? Hello?
Yes, ma'am.
Okay, okay.
Ma'am, option third is correct, I think.
Okay. So option third you found. Okay. So let us do it one by one. What is the limit of the first option?
And first is also, I think,
One.
-8.
-8.
-1 it is.
1. -1.
-1 or -8?
It is 1 only.
Okay, okay, let us check. Okay, so if I directly put -1 over there, then what we will get? 1 plus 6 minus 7, that means 0, by 1 minus 3 plus 2. That means it is coming 0 by 0, right? That means there will be a factor x plus 1, right? So let us try to factorize it then. So I guess we can factorize this as x
Factor
plus
of
1.
upper quadratic is x minus 7 and x plus 1,
Right?
right? And the lower quadratic is factor of lower quadratic is x plus 2 and x plus 1, and there
This
is
one, right?
common factor is
We can
minus
cancel it
1,
out.
so it is cancelled.
Then we can put -1 now. So we don't have any disturbance. So it will be -1
Yeah.
-7 over -1 plus 2. That means equals to -8. So the limit is -8. Okay. Any doubt?
Yeah.
Any doubt? Anyone? So the first option is the correct answer, right? And the second option is a clearly a cubic polynomial. So we can directly put the limit over there and we will get the limit, right? So 2 cube means 8 plus 4 into 2 square means 4 into 4, that means 16, minus 6 into 2 means 12, minus 7, right? That means from here we will get 4, that means minus 3. So it will be 5. So this option is also correct answer, right? What about
Ma'am,
the yeah.
in the first solution, when you induced -1, you get 0 by 0 by 0. That is understandable.
Yeah.
But how did you arrive saying that it will have one root because it is 0?
Okay. So -1 is satisfying both the equations, right?
Right.
If one is like, if some number is satisfying both the equation,
Both the
that
equation.
that
Okay.
is the root of the equation.
Okay. X plus 1. Then since x is tending to -1, x plus 1 will be the root. Okay. Understood.
Yeah.
Thank you.
Okay.
Thank you.
Clear?
Right.
Okay. Yeah. What about the second option?
It is also 1.
1. How?
Ma'am, the second is -7/2.
Right. So if first we will check whether can we put the limit like that means this point directly over there. So if there is no disturbance, so then we can directly arrive to the limit. If there is any disturbance, that means we can do something with that. Sometime we can take some factor which can be cancelled out, and sometime we can something different, like there are some other process, L hospital and all, we can apply them. Okay. So in the second equation, we can see that if I put 0 directly in the equation instead of x, we will get -7/2, which is a finite number. That means there is no disturbance. So -7/2 will be the limit. Okay. Clear?
Yes, ma'am.
Okay. And what about the fourth option?
Ma'am, it's supposed to be
Its answer is 0, ma'am.
0.
Okay.
Fourth
so we
option.
can see again, if I put 3 over there, we will again get 0 by 0, right? That means we can take some factor common, right? So from the above equation, we will get x minus 3 whole square, and this is x minus 3, right? And x minus 2 will be cancelled out. So we will get x minus 3. If I put 3 here, now we will get 0. So 0 will be the limit. So these two options are incorrect. Okay. Any doubt?
No, ma'am.
So it is clear to all of you, right?
Yeah, ma'am. It's clear.
Okay, good. Okay, we can also check. Yeah. So option 1 and option 3, these 3 options are correct. Okay. Okay. This is our question 2. So you have to analyze the graph and we have to arrive to the correct options. Okay. Again, I am giving you some time to choose the correct option. Then we will solve it together.
I think option 2 and option 5 are correct.
Ma'am, option 2 and option 4.
Option 2 and option 5.
Ma'am, I think it's option 4.
Yes, ma'am.
Okay. Option 4. Anything else?
2 and 7.
Nothing else.
2 and 7. Okay. Okay, let us check. So what is option 1? We will check one by one. Okay. Limit of the function as x tending to 0. So as x tending to 0, we have to calculate the limit of the function. So we know that when we calculate the limit of a function, that means we have to check both left hand limit and right hand limit, right? If they are same, in that case we can say limit exists, right? So first we will check the left hand limit. That means when x comes 0, but from the left hand side of it. So if x tending to 0 from the left hand side, our function is also tending to 0, right? And when x is tending to 0 from the right hand side, then also our function is tending to 0. That means when x is tending to 0, our limit will be 0, right? So option 2 is a correct option. Okay, and option 1 will be wrong because here they said the limit is 1. And also option 3 is incorrect. Okay, any doubt up to now? Any doubt?
No, ma'am.
No, ma'am.
Okay. Then what is option 4? There is a unique tangent at the point x equals to pi, but not at x equals to minus pi. Okay. So the graph is given here. So do you know which function is this?
It's a sine function, right?
What do you think?
This is a sine function, right? -1 to plus. No, sorry. No.
Sine
0 to
like
1. 0 to 1.
It is not.
So this
No.
is not a sine function.
No, it's a 0 to 1. It's very
but it is shifted to 1, right? Like one length. That means 1 plus sine x.
Yeah.
Correct?
Correct.
Yeah. So we know 1 plus sine x is differentiable everywhere. Actually,
How it is 1 plus sin x?
like if I have sine x, then the range is okay. It is from 0 to 1. Then it is not 1 plus sine x. Okay. Sorry. So okay. So the range is from 0 to 1. I thought it was from 0 to 2. Okay. So it is not 1 plus sine x.
Can we say 0.5 plus sin x? Because -1 to 1. Oh, there is pi also. Okay, sorry.
Ma'am,
Yeah.
this is nothing to do
No.
with...
Okay, it's fine. There is nothing to do with the equation, so let's not be bothered about it. Let us focus on the graph. Okay, so we know the tangent line is like at some point, if I want to draw the tangent line, then this is a line which touches the graph at that point, right? So if at pi, I want to draw a tangent line, this is the tangent line, which is a unique line, right? Again, at minus pi, this is the tangent line, which is a unique line. So at both pi and minus pi, we can draw a unique tangent line, right?
But a tangent should touch the curve at only 1 point, no?
Yes.
But it touches at 3 points, no? -1 pi.
Okay. No.
And 1 pi.
See. That's not the thing. I mean, tangent may touch the curve more than 1 point, but the point should not be in a nearer, like in near to this point. That means if you are drawing the tangent line at minus pi, that means the in a neighborhood of minus pi, the curve, the tangent line should touch the graph only at 1 point, like no other point in the neighborhood of minus pi. But in which is not in the neighborhood of minus pi, at that point tangent line can touch the graph. Even tangent line can cut the graph. Okay. Clear?
So basically, if it's a sharp curve, then it is not a tangent. If it's a smooth curve, that is the tangent.
Correct.
So that means it can touch more number of points, is what you're saying. When it's a smooth curve, it can touch more number of points, but it's very dense. in a very small area. Is that
Ma'am,
what?
Can you repeat what did you just say?
No, what I'm saying is, my understanding is tangent is a smooth curve at the point of touching the x-axis.
Yeah.
Now, if it is a sharp curve, like for example,
Sharp corner.
if it's a V curve, V shape,
Yes.
then it is not a tangent.
Yeah, because
No.
not a tangent means we can't then at the sharp corner we can't draw a unique tangent. There may be so many number of tangents. Like you can, if I want to suppose, if I am considering this point, then this line itself can be a tangent. This line itself can be a tangent. This line, even any line like that can be a tangent for that point. Okay, but if you have a U type of shape, this line cannot be a tangent for that point.
Okay.
Right?
Sure.
So if you suppose if this is our curve, okay, at that point, if I want to draw the tangent, so in the close neighborhood of that point, the tangent will not cut the curve or touch the curve. Okay, but it can touch the curve or even cut the curve at any other point which is not in the close neighborhood of that particular point. Okay. So here, the x-axis is it basically cuts the line. I mean the point 0, pi, minus pi at 3 different points. It cuts the curve, but they are not in a close neighborhood of minus pi, right? Like 0 and pi, they are not in a close neighborhood of minus pi, right? So there is no disturbance. Okay. So this line, that means our x-axis, this will be the tangent for at x equals to minus pi, even at x equals to pi, even at x equals to 0. Okay.
Ma'am.
Yeah.
So, ma'am, I think option 5 is wrong because the there are tangents at points, but they are the same tangents. They are not unique.
Okay, unique tangent at x equals to pi means at x equals to pi we have a unique tangent. That means the same line can be tangent at any other point, but at x equals to pi we have only one tangent. I mean there are no other line, other tangent line.
Okay.
Okay. So unique tangent line means at x equals to pi the curve should be differentiable. That means there should not be any sharp corner. Okay, so at x.
But at every U-shaped portion, there is only one tangent is possible. Yeah. So every tangent is a unique one only for that point.
Yeah. If it is not a sharp corner, then or there is no breakage, there is no jump, then the tangent is a unique tangent. Okay.
Okay. Okay.
Okay. So the option 5 is correct and 4 is wrong, right? Okay. Any doubt?
Ma'am, I'm checking the grade. This is from the graded assignment. I mean, practice assignment, right? They're saying that.
Yeah, in the practice assignment, we have a same kind of question, maybe. Yeah.
Yes, ma'am. In option, they're saying that option 5 is wrong.
No, then we have to check it. There may be something like which is not similar to this.
No, ma'am, it's the exact same question. I recognize it.
Okay, then in the open session, I will check it. Okay.
Okay.
But option 5 is the correct one. Okay. So at pi and minus pi, both we have a unique tangent. Because at pi and minus pi, we don't have any sharp corner. So the curve is differentiable. Hence, we have a unique tangent. Okay. Clear? Clear? Okay.
Yes, ma'am. Yeah.
Yeah. Let's move to option 6. The given function is monotonically increasing in the interval minus 0.5 pi to 0.5 pi. That means in this interval. So it is clearly not monotonically increasing, right? First it is decreasing minus 0.5 pi to 0. Then it is increasing from 0 to 0.5 pi, right? So clearly the 6th option is incorrect, right? And again, it is not monotonically decreasing in this interval. So the 7th option is also incorrect, right? So it is both increasing and decreasing. First half, in the first half of the interval, it is decreasing. Then in the next half, the interval, it is increasing, right? So both options 6 and 7 are incorrect.
What
right?
is the monotonical?
Monotonically increasing means like this. This is a same, like increasing function and monotonically increasing function is same. Like, okay, monotonically we use because it is continuously decreasing or continuously increasing. To respect this word continuously increasing or decreasing, sometimes we use monotonically.
Okay.
So in between, it should not change the course. It should always from the start to the end.
Yeah, it should not flip flop.
Yeah.
So
when
from the
because they mentioned the interval, I mean minus 0.5 pi to 0.5 pi.
yeah.
If it was like that, suppose for example, then it was
Correct.
monotonically increasing.
Okay.
But,
understood.
Shall we say between minus 1 pi to minus 0.5 pi, it is increasing, right?
Minus
1 pi to minus 0.5 pi.
Okay, so you should say it like 0.5 pi to 1 pi. Okay.
Okay. But that is this side it is decreasing, but at the negative side it's increasing.
Correct. So in this interval it is decreasing, and in this interval it is increasing. Okay.
Okay.
Got it. So it is clear to all of you, right? Any doubt? Any doubt?
No.
Okay, very good. So this is the third question. Here we have 3 formulas. So you just note the formulas. You have to keep them in your mind. And using these formulas, you have to calculate these limits. Okay, you just have to balance it and calculate it. Again, I am giving you some time to solve it. You just solve it and let me know the answer.
Ma'am, we have to match the left three to the options, or what is expected here? Or it's only one option, or
No, these are formulas. You have to use these formulas to solve these options.
Yeah. These 3 are some formulas given here.
right?
Okay. And you have to use these formulas to solve these options.
Okay. Understood.
Okay. Yeah.
Ma'am, option 1, option 4, and option 8 are correct.
Okay. What about others?
Option 1, option 4, and option 8 are correct.
Okay. So let us solve it one by one. Okay. What about the first option? we have 2 limit extending to 0 log 1 plus x by sine x, right? So we can use these two formulas here. If I just multiply 1 by x with both, then we will get this, right? Then we know the division rule. So we can apply the division rule. So this will be 2 limit extending to 0 log 1 plus x by x by limit extending to 0 sine x by x, right? So it will be 1 by 1 into 2. That means the total limit is 2. That means the first option is correct, right? Any doubt?
No. So second option automatically gets wrong because
Yeah.
the first option is correct.
It is automatically wrong. And if the third option, we can like multiply 3 here and divide it with 3, right? So this limit will be 1 and 3 is there. That means the total limit should be 3, right? Clear? So the option is incorrect. Okay.
So then,
Please explain. You
Okay.
multiply divide by 3. So
Yeah.
sine 3x by
So
3
we
becomes
have
1.
limit extending to 0 sine 3x by x, right?
By
So we can
3.
multiply it by 3 and divide it with 3. Okay.
Okay.
So this limit becomes 1, right?
1. Okay.
And we have 3. So
Okay.
the total limit will be 3, right?
3. Okay. Okay.
So option 3 is incorrect and 4 automatically becomes correct, right? And the same thing in option 5. We have to just do with 5 what we did with 3 in option 3 and 4, right? So the answer in option 5 should be 5, not 1 over 5, right? So this is also incorrect one. Any doubt up to now?
option 5 is x. When you induce x equal to 0, it will be divided by 0, right, ma'am? That's so.
No, see, you can again we can do the same thing, right? 5 and 5. So this will be again 1 and we'll get 5, right? Not 1 by 1.
Right. Okay.
Right? So option 5 is also incorrect. What about option 6? We can similarly balance it, right? So e power x by 5 minus 1, we can divide x by 5 into 5 by sine 5x by 5x into 1 over 5, right? Then this portion will become 1 from this formula and this portion will become 1 from this formula, right? So we will get 1 over 5 by 1 over 5. That means 1 over 5 by 5. So this will be 1 over 25, right? Clear? Any doubt?
Once more, ma'am.
No, it's clear. Can you break? It's too complicated.
Yeah. So if I put the limit here, it will be 1 over 5 because of this 5. This is 1 over 5, right? From this portion. From this portion, we will get 1 over 5, right?
Term? Both the terms, you divide by which term?
Okay. Let us do it in more simpler way. So we have e power x by 5 minus 1 by sine 5x. So here we need x by 5, right? Correct? So we will multiply it with x by 5.
Okay.
Right?
No, why? How did you get that x by 5, ma'am? How did you arrive at that?
Here we have x by 5.
Right.
If you follow this formula, e power x minus 1 by x. So we need by x, right?
Okay.
So we need x by 5 here. So we will multiply the term with x by 5 and we will divide the term with x by 5. Okay. Fine.
To get, okay.
Then again here we need 5x, right?
X minus 1 by x.
Right? Here we need 5x, correct?
Okay.
Because we want to apply
Yeah.
this formula.
First
sin x.
formula.
Yeah.
First formula.
Then
Okay.
we have to multiply it with 5x sign, right? So if I simplify it, x and x will be cancel out, right? So in the next step, this 5 is actually 1 by 5. So it will be multiply with this 5. So we will get e power x by 5 minus 1 by x by 5. Then 25 into sin 5x by 5x.
Okay.
This, right?
Yeah.
Yeah. Now if I apply the limit extending to 0, LT 0, LT 0, then it will become 1 and it will also become 1. So in a total, we will get 1 by 25, right?
Yeah.
Clear?
Correct.
Okay. So the option 8 is correct and 6, 7 and 9 are automatically wrong. Any doubt?
No.
Okay. So what about others?
So technically, we are only solving 3 options. Actually, we invariably, if you solve 3, then remaining will be
remaining
automatic.
are automatically,
Okay.
Automatically done.
But when you really look at the question, it really
it's like we have to solve 9 different
it's very intimidating.
Yeah. So it's not like that in reality.
Okay, right.
Okay. So don't have any doubt, right?
No
Yeah,
doubt.
it's clear.
Okay. So we can move to next question. So we can also check 1, 4 and 8 are the correct option.
But these are the real questions, ma'am. Actually, this is the real question, or from any practice or anything?
No.
Or?
These are not from any practice or.
Okay, you are
just...
okay, from some other. Okay.
Yeah.
Because I never seen such a question like having 9 options. So I was
These
not
are
sure.
just for like practice purpose.
Yeah. Understood.
Yeah, just to build up our concepts.
Right. Understood.
Okay, another one. This may look like something challenging. So I'm giving you some more time to solve it. You just try to balance this equation. We have these 4 formulas. Using these 4 formulas, we have to solve this limit. Okay. So this is e power the whole thing. And we have to calculate the limit. You have to balance the equation in such a way so that you can use the formulas and calculate the limit. Okay, I'm giving you more time. Like you can take more than 5 minutes, but try to solve it and let me know the answer. Yeah.
E raised to the whole thing?
Yeah, e raised to the whole thing. You have to just balance the equation in such a way so that we can apply the formulas. Okay, you just try to balance the equation and that is enough.
So ma'am, we have to remember all these things.
Yeah, it's good to remember the properties and in the formulas at least.
Ma'am, I got the answer. Answer is 1 upon E square.
1
Maybe
upon
minus 1 upon E square.
minus 1 upon E square. This one?
Minus 1 upon E square, I think.
This one? Okay.
Yeah.
Okay. Let us check the answer. So the answer is 5. Somehow we got the wrong answer, but let us see where is the connection. Okay.
Now the second term it becomes minus
Am I
1, right?
wrong?
0 minus second term becomes 0. I think.
Where
Okay.
is the answer?
The
Okay, let us check. So this is the answer. Let us see the solution. Okay. So this is what is given to us, right? Now we can adjust. First, we have to use this formula log 1 plus x by x. So we will multiply this term with 6 over n and then again we will divide it with 6 over n. Okay. Similarly, we want to use the second formula for this one. So again, we will do the same thing. We will divide it with 1 over n and then we will multiply it 1 over n. Okay. And again, here we will use this third formula. Okay. That's why we need n factorial over 1 over n for this x factorial. So we will again divide it with n factorial over 1 over n and we will multiply it with this. And here we multiplied it with n, so we divided with it. Okay. So it is just multiplication and division. That's it. So
no,
the second, yeah.
I didn't understand this last. The first two terms are okay. The n factorial to the power of 1 by n. How you got that, ma'am? That part.
So we want to use this, right? So we want x factorial over 1 over x, correct? Right?
Okay.
That is why we took.
No, which one you are using? Which form are you using for n factorial to the power of 1?
The third one. Yeah.
Okay.
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 So
we have to bring
express
the
it
two
as n into root over 2n pi by n factorial whole to the power 1 over n, because 1 over n is already there, right? So we want this. Okay.
Okay.
And because we divided this thing, so we have to for balancing we have to multiply the whole term with this, right? And again we need a x here, so we need a n here, so we divided it with n and then we multiplied it with n. Okay.
No, that.
But why do we divide that 6 by n as 6 by n factorial?
This one?
The second line, second term.
Second line.
Second line, the first term, the second.
Okay. So this step is clear, right? Then I'm going to the next.
Yeah.
Okay. Now here we have this thing, right? N factorial to the power n. We can take this inside the bracket. Okay.
Oh.
Okay. Here we are taking this inside the bracket. Okay. So 6 by n we already have, and we took this inside the bracket, so we got this. Okay. So this is basically 1 over something. That means it will be that something. If I multiply this, and this will be 1 over this. These are basically same, right?
Ma'am, can you repeat the last thing what you said?
This one?
The last thing from which identity when
You
you divide it by
e power, that power alone you are taking inside, right?
Yeah. So you have this n factorial power 1 by n here, right? Outside the third bracket, we are taking this inside the bracket. So it will be multiplied with this term, right?
Okay.
So then we will have this term, suppose this is our x, okay? And then we will have n factorial power 1 by n into our x, right? So we can write it as 1 over n factorial. That is what they did here, okay?
No, it is a multiplication only. Now, why it goes below the denominator?
That is why I'm saying, na, like 1 over some number means what? This
That
number
is okay,
itself.
but it is into 6 by n into n factorial square, n root of n factorial only, no? Why it goes to the
That
below?
is what I'm saying, na. 1 over, this is our 1 over this number. So this will become the
Why
number
it
again.
below 1? It should come near next 6 by n into n root of n factorial only, no?
Okay. See. Let me write it, then you can understand it. Okay. So see, we have log 1 plus 6 over n by 6 over n into 6 over n, right?
Yeah.
And we are
Right.
multiplying this, means we have into n factorial power 1 over n, right?
Okay.
So in the next line, we can write it as log 1 plus 6 over n by 6 over n into 6 over n into 1 by n factorial power 1 over n, right?
How that is possible? 1 over n factorial 1 by n.
Now,
Oh, okay.
1 over some
Yeah,
number
yeah.
is that
Okay.
numbers itself, right?
oh,
Yeah. Okay. Understood.
Right? So
Okay.
now you can multiply this two terms, so we will get this, right?
But why you need 1 over 1? So technically, what you are saying is you are actually dividing this n factorial to the power 1 by n. You are dividing it 1 over n factorial to the power 1 by n will lead to 1 by n factorial to the power 1 by n. But your term is n factorial 1 by to the power 1 by n, right?
What?
Ma'am, you're essentially just rewriting the same thing, right? In a different.
Yeah. I'm just rewriting the same thing. I mean, this means this, right? There is no confusion in it, right?
No, the denominator is n factorial to the power of n or n factorial to the power of 1 by n. What is that in the denominator? It's not clear.
Okay, from here, if you just multiply them, so in the denominator here we have n, and here we have 1 over n factorial power 1 by n. So if I just multiply them, it will become n over n factorial power 1 by n, right?
yeah.
Okay, just forget about this term. We have 6 over n into 1 over n factorial power 1 over n, right? So you can take this as the number. Now, if I just multiply it, it will become 6 over n factorial power 1 over n, like that, right? You can consider it as n by 1, and this is 1 by n factorial power 1 over n. So if I just multiply them, it will become 6 over n by n factorial power 1 over n. Okay?
So I think probably the way I should understand is 1 over n factorial to the power of 1 by n is nothing but 1 by 1 by 1.
Yeah.
1 by 1 by 1 by 1 to the
From what you were explaining, 6 upon n upon 1, you are
So this term we are taking inside the bracket. That means we are multiplying
from where
the term with
which step you were explaining, ma'am?
this step, the third one.
Okay.
So we have the multiplication over there. That means basically we had 6 into n root of n factorial, right? So we can take this over here. So it will be, we can take this over here also. This is the same thing. Okay?
Yeah, I understand.
Any confusion?
Yes, no, ma'am.
No.
So then how does the log one stay the same? The log 1 plus 6n over 6n.
Yeah, this
you're-
is the same, right?
Yes, ma'am. That's because you're like how does it
We are
stay?
just multiplying, no? So we need not to change this term. We are just multiplying this simply.
Oh, you're multiplying it all together. You're not multiplying to both of them.
No,
Yeah.
you have to multiply it both. So we first multiplied with this term and we have to multiply it with this term too. So here we multiplied it with this term, right?
Yes, ma'am.
Yeah. So this up to this term is clear, right?
Yes.
Yes.
Yeah.
Yeah.
Yeah. So here, this is what is written there, right? And now we are taking this. So 1 by n is already there. We are multiplying n root of n factorial. So this term is like that. This is also clear, right?
Yes.
Now if I just write this term as simply, it will look like that. And take this n here. So it will be like that. Okay. Okay. So the third step is clear, or if you have any doubt, you can ask. The third step. This step. Is it clear now? Any doubt? Any doubt?
Where did that n gone?
No, ma'am.
The second term
This here.
here before that step. There is
Which
one.
n? Which n? This n?
No, not that one. The next.
This one?
1 by yeah.
This
Where
one?
is that?
Here.
Yeah, that 1 by n into 1 by n.
Here. This is the term. Like we have 1 by n into n factorial power 1 by n. Na? So we are
Yes.
writing this as this. These things are simple, right? 1 by something into something means what? That something by n.
Okay.
Okay. So
Wait. N factorial
this
power 1 by.
multiplication we are writing like that.
Oh, this n is merged with that term. Okay.
Yeah. Okay. Fine.
Okay.
Fine. This step is clear now?
Yeah.
Okay. Now we are taking 1 over x equals to n in some places where we need extending to 0. Okay. So
Please
if I...
wait, where that denominator is gone? That
What?
n factorial power 1 by n, that root of 2 pi r. Below that there is one denominator, no?
Yeah. This...
The previous step. N
Yeah.
into
Here we
r.
have n factorial.
Okay.
So you just take 1 by n over the whole thing, like root over 2 pi
Okay.
n
Here
by
it is.
n
Yeah,
factorial.
I got it. Yeah. Divided by n factorial. Okay.
Yeah.
Yeah.
Okay.
Okay.
Yeah. Okay. So if I take the logarithmic thing, so we need extending to 0, but we have n tending to infinity. So if I take 1 over n equals to x, so as n tending to infinity, x will tend to 0, right? Similarly, for the exponential one also, we need extending to 0. So here also 1 by n, we will take as x. Okay. Now, after taking this, we will express this equation in this form. So here we took x. So we will express this like we will replace n of n by x. And here also we will replace n by x. So we will get the limit as 0. Okay. And here we will directly put the limit for these two formulas, and these two terms are same, right? So these two will be cancelled out and this will be 1, this one. Okay, fine up to this step.
Now, how do you change the limit? That is 1 by n equal to x. How do you arrive that?
Okay, so you can substitute the limit by one number and you can then recalculate it. So if I take 1 by n equals to 1, so we know that we have the limit n tending to infinity, right? So because 1 by n equals to x, so when n is tending to infinity, x will be tending to 0, right?
No, I don't understand. How do you say 1 by n equal to x?
We are substituting 1 by n equal as x.
From where you get the 1 by n?
1 by n is already there, no?
Oh, here. Oh, from that term, you're taking 1 by n.
Yeah.
Okay.
So
You are just assuming 1 by n as x.
The
right?
thing is, we are just simplifying the equation. Okay. So if
Is
I
it
assume
assumption or
x
you arrived
equals,
the value?
yeah. So if I just for simplification, if I take x equals to 1 by n, because limit n tending to infinity, then x will be tending to 0, right? So here if I take the limit inside, then we will get limit n tending to infinity, then this term. So if I express this whole n by x, then we will get this, right? When n tending to infinity, we found that x is tending to 0 and we are expressing 1 by n in term of x. So we will
How do
get
you say when n tending to infinity, how x tends to 0?
1 by infinity is what?
1 by infinity is infinity only, no?
No, 1 by infinity is tending to 0.
Oh, okay. Okay. I don't
And
know that.
1
1 by infinity is 0, right?
Yeah. 1 by infinity is 0.
Okay.
Okay.
Okay. Then still I'm not clear how you get 1 by n is equal to x.
We are assuming 1 by
Assumption. Okay, right. Okay.
for the simplification.
Okay.
Then it is again same. We are not changing anything here. Here we are again doing the same thing. 1 by n is equals to x and we are just substituting x instead of 1 by x. And here nothing is changed. So everything is same. Okay. So is this step clear?
So wherever 1 by n is there, we are changing the limit to x tending to 0.
Yeah. Wherever we want the limit as x tending to 0, we are substituting this.
Okay.
Okay.
Okay. Because to suit this formula.
Yeah. Correct. Fine.
Yeah.
Okay. Then we will put the limit. Okay. So here we have the first limit. So this will be the first limit, 1, right? So we will get 1 here. Then 6 will be as it is. Here we will use the last formula, which is E. So we will get 6 over E. So the first, this term will be 1 into 6 over E. Similarly, for the exponential, that means this thing, we will get the limit as 1, right? And for this thing, again, we will get the limit as E, maybe, right? So yeah, this limit is E. So we will get the limit as E. Okay. So 1 over E into 1. That means this is a final limit. Okay. Is it fine?
Yeah, it's clear.
Okay. Then we have to just calculate it, right? So here we have E. And then here we have 1 into, like, basically E, 1 over E we can take at common. So E and E will be cancelled out. Okay. So we basically have 1 minus 6 minus 1.
In the fifth term in the bracket, the whole term is power to the e. No.
How? No. This is multiplied it with E. Like E into the whole thing. Okay. E multiplied by the whole thing.
But you no,
yes.
In the beginning you say this of whole,
I said it, but it is actually like multiplied it with E. It is not E raised to the whole thing. It is E into the whole thing. Okay.
Okay.
So E will be cancelled out and we will get 6 minus 1 means 5. Okay. Any doubt?
No, ma'am.
Okay. What about others? Everyone is okay with this?
Yeah, ma'am.
Yes, ma'am.
Get this sort of questions.
Not that much complicated question we will ask in the exam. Okay. So in the exam, we will ask some simple question. Don't worry about it. Okay? This is just for your practice purpose. Okay.
And what is the use of this in real world, madam? Like, is it required for anything?
So the limit is a very basic thing. And there are so many developments over the limit, continuity, and differentiability things. Okay, it is a very basic thing, and like it is kind of a base of a mathematical pillar. Okay.
Okay.
There are so many development. I mean, there are so many applications of limit in physics, chemistry, biology, and like in every stream of science. Okay.
Oh, okay.
Yeah. Okay. So this is the next question. Question number 5. So just take your time to solve this question. Let me know the answer.
Basically, this we have to find the limits for the three algorithms.
Yeah. Yes.
Then you will say which is the highest error, which is the lowest
Yes.
error, right? That's
Correct.
understanding. Okay, right.
Sorry. What are the limit you are getting? What is the limit of the function, the sequence an?
Ma'am, for an it's
N is 0.857.
ma'am for limit for a1 an it's 1.
Okay. So
And then-
let us check. We can rewrite an as 1 plus 5 over n by 6 plus 1 over n square, right? We're taking n square as common, then we're cancelling it out. So if n is tending to infinity, this term will tending to 0 and this term will tending to 0. So it will be 1 over 6. And what is the, like after doing the point, what is the decimal thing? 0 point?
0.16, right?
0.166.
Okay, so it is fine. Is it fine? The limit of an is 0.166. Yeah. So the limit of bn is 1 over 8. Because if n is tending to infinity, this term will be tending towards 0 and this is either minus 1 or plus 1. Whatever it is a finite number. So a finite number multiplied by 0 means it will be 0. So the limit will be 1 over 8, right?
So basically here n belongs to natural numbers excluding 0 means it's infinity. Indirectly you're saying it's an infinity limit.
Yeah. Whenever we
Okay.
are calculating limit for a sequence, we will automatically take n tending to infinity.
Yeah. Okay.
Okay.
I was thinking differently. I was actually calculating starting with 1, 2, so that whether it is decreasing function or increasing function. That was my understanding, but I think you have a different view. Okay, understood.
Yeah. So whenever you are calculating limit, you will always take n tending to infinity. Okay.
Right.
Yeah. So the sequence bn will be tending towards the point 1 over 8, right? And what is it in the point?
0.12.
0.1.
125.
5.
1 to 5. Okay.
Third one, it is 1 by 7.
Yeah, 1 by 7 plus 4 by e power n. So if n is tending to infinity, e power n will be tending to infinity. Hence 4 by e power n will be tending to 0, right? Hence the whole limit will be tending towards 1 over 7, right?
Yes.
And what is it in point?
It is 1.14.
0.1.
Sorry, 0.142.
142. Now we can check the options. So error estimated by algorithm 1 will give the maximum error. So if the limit of n is maximum or not, we have to check it. So the limit of n is actually the maximum one, right? 166 is greater than 125 and 142, right?
Yeah, maximum error. That's true, correct. First one is correct.
And the first one is correct. The error estimated by algorithm 3 will be the minimum error. So the limit of
that's also correct. That's also correct. No. Sorry. Yeah.
Limit of bn is minimum, right?
Yeah, B is minimum, correct.
Yeah. So the limit of cn is not minimum. Hence the second option is incorrect, right?
Right.
Both algorithm 1 and algorithm 2 will give the same error and that will be maximum. Is it correct?
No, it's false.
No, right? So we can directly check the limit of an and bn are different, right? Error in estimated by algorithm 1 will be 0.66 approximately. It is correct, right? Right?
Yeah.
We already calculated it. Error estimated by algorithm 2 will be 0.125. So this is also correct, right?
Yeah, I heard one small hint to calculate the mixed polynomials of various degrees. If the denominator and the numerator has the same degree, then limit would be the coefficient of the highest power in that is it is the same only, no, the coefficient of denominator by coefficient of
denominator
numerator by denominator. Okay,
yes,
no
correct.
need to supply these things No need to do
Yeah,
all.
yeah. This is a direct thing, like direct step of doing all this. So in the background, we are doing these things actually.
Okay, if
So
the numerator degree is less than the denominator degree, then the limit will be 0, right?
yeah, correct.
Okay, and if the numerator degree is higher than the denominators,
Then the limit will be
does
infinity.
not exist.
Infinity, that means doesn't exist. Yeah, correct. Okay. So that
Okay.
means these are the correct option. Any doubt in this question?
No, ma'am, it's clear.
Okay. So yeah, it was probably the last question, and yeah, it was the last question. So yeah, now if you have any doubt, anything to ask, you can ask. Any doubt? It can be from this session. It can be like other than these things. Anything?
Ma'am, what are the syllabus of in-term exam?
End term. End term is the whole syllabus. I
Yeah.
mean, from week 1 to 11, all the weeks.
Okay.
Okay. In quiz 2, we will ask questions from 5, 6, 7, and 8. And in end term, there will be from week 1 to week 11. Okay.
So for quiz 2,
Ma'am, these questions are important for in-term exam.
What?
Week 1 to 4 is not covered, only 5 to 8?
Yeah. Quiz 2 is only 5 to 8.
Oh.
1
Not
to 4,
Ma'am,
no, not 1 to
these
4.
questions,
Yes.
ma'am, these questions are important for in-term exam
Yeah. Yes.
that you have done.
Yeah. So the polynomials type of thing, that means n square and all, these questions are important in the point of view of exam also. And we will not ask any kind of complicated example in exam. So you just we will just ask in this type of simple polynomial questions. Okay. So just try to clear your basic, and it is enough. And if you are more interested, you can solve. You can take any book, and you can solve the questions so that you will get more comfortable with the limiting concepts.
Can you tell me, ma'am, book? Can you suggest me a book for solving a
Okay, so
question?
there are
This
books for
have
Math 1 course also. You can find it in your calendar or maybe in your portal. And also, if you want me to suggest something other than that, so what I followed in my beginning days, it was real analysis by S.K. Mapa. Okay, so there are plenty of example in that book, real analysis by S.K. Mapa. So you can follow the book.
What can you spell it, ma'am? SK?
SK Mapa, MAPA, Mapa.
MAPA. Okay.
Yeah, SK Mapa, Introduction to Real Analysis by SK Mapa. You can follow that book. There are plenty of example of limit, continuity, and differentiability, L hospital rules, and all. Okay.
Okay, ma'am. Thank you.
Yeah, welcome. So if you have any other doubt, you can ask. Otherwise, I will end the session. I'm waiting for some time. If you have any doubt, you can ask.
Will this be useful in projects or how?
Which things?
This concepts that you are teaching now.
Okay, so as I said, it is a very basic thing. I mean, in future, there will be so many applications of these things. Okay.
Acha, okay.
Okay, so these things are really important. I mean, the basic should be always clear. Otherwise, you cannot build your tower, right? So
Correct. Basics is enough, not more
yeah.
complicated. Correct, madam.
Yeah, I mean, you don't have that much complicated thing in your syllabus too. Okay, so which is in your syllabus, it is already the simplest thing of limit, continuity, and differentiability.
Okay,
I
madam.
think the question, if I understand right, it was more to how these limits will be used in the data science
No, that's what
topic.
that's what. If we use it in the real application,
Yeah,
maybe.
yeah, that's I
Oh,
think that's the question I understand, but I don't know.
no, that is the major requirement actually.
You will come to know only after completing
No,
the
I'm
data
into this
science.
Yes.
health. No, no, I'm into this
Yes.
healthcare actually. I have to, develop a mimic of a project. So that is the thing.
So in the coming years, whenever you will do some theorem or all, there may be the application of limit and all. So whenever you will complete the courses, you will get to know about the
Prob problem
application.
is problem. I don't know how what is the thought process of other people, but we came with thinking that we learn data science, but the people have built such a big mathematics, statistics.
Yeah, mathematics is
No,
mathematics
no,
and
I
statistics is
understand.
base, na. So
Yeah,
you
yeah, yeah.
just you should be very clear and comfortable with the
Hmm.
base first. Otherwise, how will you move forward, right?
No, madam. We had an assumption that
That's a
the course curriculum will be similar,
hmm.
to, helping in the project. Well, I thought like that, but this is, I
It's a
am from this
yeah.
reliance.
It's I
I am.
understand where you're coming
No,
from.
no.
It's been
In any computing course, in any engineering course is incomplete without mathematics and statistics. So you have to
I'm
learn
from
those things
mathematics,
first.
madam. Last 12 years, I
uh,
forgot everything.
no,
I've
no.
done this reliance.
Okay, then these
No,
things should be
no,
easy for you.
no. I think I think I mean, it's not fair to express personal views, but nevertheless, my point of view is we are coming from an application background, but probably
Yeah.
who is defining the syllabus is coming from the pure subject point of view. So there's a disconnect between what a practitioner is expecting out of this course versus the theoretical.
No, these are these things are pure topic, but this pure topics also we are doing from a applied approach. So
Yeah,
this
yeah,
is not the pure. There are so many
correct.
like epsilon delta definition and so many things in limit
Yeah,
continuity. Like there are so many things
yeah,
which is
sure.
analysis,
Correct.
but we are doing it in form of applied approach.
Agreed. So, for example, to make it more simpler, if
Mhm.
you go back to that error problem, right? You just discussed about that error,
Yes.
maximum error. So that part I can correlate with what we do normally.
Yeah.
So we can understand, okay, if this is how the real problem comes. This is how we need to calculate the error, which is a
Mhm.
direct relationship with what we practically do on a daily basis.
Mhm.
But when you talk about the one which we discussed about the logarithmic and rebalancing the equation and all, probably that's a big disconnect between our question is, do we really get such a thing in a real scenario? That is the disconnect. I mean, very.
Yeah, I got your point. But yeah, the pure things you cannot directly apply to something real life
Yeah.
type thing. But in like if you want to apply something in your real life, so like to do that you need this thing. These are
Yeah.
basically the background thing.
But these are all very interesting, but managing time is the tough
Yeah,
part.
I can understand. So you have to manage 4 courses together, maybe, right? Right now, how many courses are there?
4,
No,
madam.
I have only 2 maths and stats.
Okay. Yeah,
But
that
not
I
is
have
managing
2 courses.
2 courses are there only, right?
direct entry, so I have only maths provisional entry. So I have only maths and stats.
Okay. And what about others?
I have opted for 4, madam, actually.
Yeah, okay. So, yeah, I can understand the pressure, but yeah, we have to somehow manage it. How, like,
No, I just have to prepare myself on, what I have to do next 10, 13 days is, it is going to be something different. So I just want to check whether, is it, mainly related for anything on the,
next 2 week it will be like pure calculus. And yeah, even next 3 week it will be pure calculus. Okay, then you will get your graph theories.
Okay, madam.
Yeah.
Thank you, madam. Thank you so much.
Thank you.
Yeah.
Thanks.
Thank you. Bye.
Okay.
Ma'am, can you please enable that whatever session, because last session we couldn't access
Session. Yeah, I will update
yeah,
just
sure.
after the
Right.
session. I will update it.
Right.
Yeah.
Thank you.
Yeah. Okay. Good night, all
Bye.
of you.
Bye. Good night. Bye.